I'm going to discuss moles and molar mass today. Moles and molar mass. I'm going to define them, tell the relationship between them, and I'm going to solve a few problems involving these two concepts. So moles it's just a name for a quantity of things. It's a name given for quantity of things. Right? So for example, when I say 1 dozen, you know that is 12 items. When I say 1 pair is that's 2 items. And if I say 1 mole, that basically means 6.02 times 10 to the power 23 items. The only difference is in chemistry we don't really say items, we say atoms, molecules, formula units, electrons, ions, etc. And this is special number 6.02 times 10 to the 23rd. This one has a name. It's called Avogadro's number. Okay. Now let's look at what molar mass is. Well, molar mass basically it's the mass of a compound. So in other words, in compound it's the addition of its components' relative atomic mass, and it's expressed in grams. So let me write that definition. In compounds, the addition of its components relative atomic mass, and it's expressed in grams. Grams, okay. So for example, if I ask you what's the molar mass of sodium chloride, NaCl, that's sodium chloride, all you have to do is look at the periodic table and find the atomic mass of sodium, which is about 23 grams, atomic mass of chloride, which is about 35, and you add them together, that should give you about 58 grams. That's the molar mass of sodium chloride. There is a relationship between the molar mass and moles, and that is this 58 grams of sodium chloride actually equals 1 mole of sodium chloride. So the molar mass of X equals 1 mole of that X. Okay, and X could represent compound, molecules, atoms, all those things. All right, let's solve some problems. 1 mole of X equals to the X molar mass. Okay. So for example, number 1, let's say we have the question: how many moles are there in 32 grams of H2O, which is water? So example 1, how many moles are there in 32 grams of H2O water? And we could solve this problem in 2 steps. Step 1 is to calculate molar mass. I'm just gonna write mm for molar mass, and molar mass of water. And the reason we do that is because we know there is a relationship between moles and molar mass. So once we find the molar mass, we can convert that to moles. Okay, and to find the molar mass, as we have already done for sodium chloride, all you have to do is look at the periodic table and look at periodic table for the atomic mass of hydrogen, and that is about 1 gram. Okay, 1 grams, but there are 2 of them, so you multiply that by 2, that's a total of 2 grams. Atomic mass of oxygen, and it's about 16 grams, and you multiply that with 1 because there are only 1 oxygen in H2O, so that gives you 16 grams. So the total is 18 grams. That's the molar mass of water, and we know that is also not just a molar mass of water, 18 grams, that's also 1 mole of H2O. There you go, there we have that conversion factor right there. Step 2 is dimensional analysis. And if you guys have problem solving this kind of math using dimensional analysis method, then I have a video, so you guys can go back and watch that video, because we are gonna need that concept to solve this problem right here. So in dimensional analysis, the easy way to is to follow the steps, right? Given, first the unit given is grams, and our target unit is, in this case, it's moles. Okay, and now we go ahead and do the actual math, which is we first write the given value, which is 32 grams. Multiply that, you make a fraction, you want to get rid of grams, so write grams at the bottom, and here is the conversion that we need. 18 grams of H2O equals 1 mole of H2O, so it's 18 grams equals 1 mole of H2O. Okay, and we cancel grams and grams, we are on moles. That's our target unit, so you make a fraction, multiply the top, right on the top, so 32 times 1 is 32, the unit left is mole of H2O. The bottom is 18 only, there is no unit, so you just simplify that, and the answer you get is 2 moles of H2O. So that's our final answer. There are 2 moles of H2O in 32 grams of H2O. Let me give you a slightly complicated one. Let's say if I ask you how many molecules are present in 171 grams of this big compound C12H22O11. So let me write that down. So let's say, example number 2, I ask you how many molecules are present in 171 grams of C12H22O11. That's the question, and the two key words are molecules and grams. Step 1 is going it's always going to be calculating the step 1 is going to be calculate the molar mass. So calculate the molar mass of this compound. I'm not going to write that compound. So to calculate that, you have to do is, so write carbon. Look at a periodic table. Carbon has about 12 grams. There are 12 of them, so you multiply that by 12. That should give you 144 grams. We have hydrogen next. In periodic table, you see that hydrogen has 1 grams, and there are 22 of them. So multiply that by 22. That should give you 22 grams. And we have oxygen has 16 grams, and there are 11 of them. So write 11, multiply, and then you get 176 grams. Okay, this 12, 1, and 16, those are the numbers that you can find in your periodic table. Now when you add them together, you get 342 grams. That's the molar mass of this compound. But 342 grams also equals 1 mole of C12H22O11. Okay, that's our conversion factor, and that's important for this problem. Now step 2 is also the same step that we did in our last problem, which is dimensional analysis. Again, if you guys have a problem solving this kind of math using dimensional analysis, then I recommend go and watch my video on dimensional analysis. Okay. And in dimensional analysis, that two step that I like to follow is to write given and target unit. Okay, our given unit is grams and our target unit is molecules. All right, and then now we do the actual math. So we always write the given first, 171 grams of that compound. Multiply that, we do not need that gram, we want to cancel that out, so write grams at the bottom. The unit that the conversion factor that we know is that 342 grams of that compound equals 1 mole of that compound. So 342 grams of that compound is 1 mole of this compound C12H22O11. Alright, and you cancel grams and grams. Okay, the next step is to see if we are on our target unit. We are on moles, our target unit is molecules, so we are not there yet. Now here we use the relationship between moles and Avogadro's number. Remember I told you 1 mole equals 6.02 times 10 to the power 23 items. In this case we are talking about molecules, so that's the relationship that we have to use. So we want to get rid of moles, so write mole at the bottom. 1 mole equals 6.02 times 10 to the power 23 molecules of this big compound C12H22O11, and you cancel moles and moles. Now you are left with molecules, and that's our target unit. Now all you have to do is multiply the tops and write at the top. So make a fraction, you multiply 171 times 1 times 6.02 times 10 to the power 23, and you get 1.03 times 10 to the power 26 mol. I'm just going to write molec for molecules of that compound. And the bottom one is you have over 1 here, so 1 times 342 times 1 is 342, and we do not have any units left. So the final answer, when you simplify that, is 3.01 times 10 to the power 23 molecules of C12H22O11, and that's our final answer. Again, the reason that we used molecules for this particular compound is, as I said, this unit could be anything. That could be atoms, that could also be electrons or ions or formula units. If we are talking about ionic compound, we usually write formula units. If we are talking about non-ionic compound like this one, we write molecules. If we are talking about monoatomic elements in periodic table, we write atoms. So that unit could vary depending on what kind of compounds we're discussing.